So we are trying to grow oyster mushrooms inside switchgrass bales in order to break down the lignin inside the switchgrass to make it easier to make ethanol out of the switchgrass. This is important because lignin is what provides the structure for the plant, but also traps the sugars that we want inside the plant to keep the enzymes that we use to make ethanol from penetrating and breaking up the carbohydrates. So we have a kiddie pool set up outside to soak the bales. When we did this the first time, we had 5 kiddie pools with 6 bales each to soak the bales for 24 hours. We flipped them about halfway through to make sure that they were nice and wet, because we want them to be at least 50% moisture, so we need them to start as high as we can get them, and that way we don't have to add a lot of water, because water doesn't saturate in grass very well, so we needed to soak them for a while. We split the bales in 4 places and placed mushroom grain spawn, drip hose rings, and temperature sensors between the bale flakes. Once the bales were inoculated and the equipment was installed, we put the bales back together and used ratchet straps to reform and compress the bales back to the level they were prior to inoculation. The bales were then hung on strain gauges that are attached to the testing rack. The weight of the bale is used to determine the moisture content. An automation system adds water to the bales when the moisture content drops below 50% or when the internal temperature exceeds 120 degrees Fahrenheit. The primary purpose of the automation system is to create an ideal growing environment for the fungus in terms of moisture availability and temperature. Today we are going to sample the first set of bales. So we will take down 9 bales and do 3-foot core samples, which basically we are going to drill through the bales in 4 different points. So we will have to open the bales up and take out all the drip hose that we put in when we inoculated them. And then we're going to take pictures and things, but then we're going to put it back together and drill through. The core sample is put into a bag and immediately weighed. The samples are dried for at least 48 hours and weighed again. The differences between the wet and dry sample weights give us an estimate of the bale moisture content. The samples are ground to a size of 3 millimeters using a Wiley mill grinder. After grinding, the lignin in the samples is broken down further with a liquid hot water pretreatment. Compositional analysis is completed on each sample to determine lignin and sugar content. The pretreated samples are then sent to the University of Arkansas for enzymatic hydrolysis to quantify how much sugar will be available for the yeast to use during fermentation. We're hoping that by using these oyster mushrooms, which selectively degrade lignin, that we will not have to use our chemical pretreatments as severe in order to make the ethanol. This biological pretreatment could also reduce the energy required for grinding prior to conversion. This project will be successful if we can confirm that the lignin degradation is significant and changes over the storage time. We will also be looking for improved glucose yields compared to raw switchgrass, which means improved ethanol yields. The overall goal of this project is to reduce the production costs and improve ethanol yields from switchgrass.